question here, part A. What do you need to do? Okay, as you can see, what do we mean by we taking A as positive there? Because you see this 5 kg here, this is diagram, this 5 kg is heavier than the 3 kg. All right, so if we don't even just common sense, the particle here, the host of the system is going to be moving anti-clockwise. Okay, so therefore this weight here, 5g, must be bigger than the tension. And on the right hand side, when it's going up, this tension here has to be bigger than the weight, 3g. So let's do when it's going down. We're resolving when it's going down here. Applying again Newton's second law of motion, force equals ma. Okay, so we're going to say 5g minus t equals 5a. Done. When it's going down. When 3 kg is going up, okay, when it's going up, all right, the tension must be bigger there. So t minus 3g equals 3a. All right. Back to GCSE solving simultaneous equation, question 1 and question 2. What must you do? Okay, all right. Add them up. Add them 1 and 2. We'll get rid of t. So 5g minus 3g. 5g, sorry again, back. 5g minus 3g, or 5g plus minus 3g gives me 2g here equals 8a. This implies that a has to be 2g over 8. Okay, 2g over 8. Simplify, you get g over 4. Plug that into your calculator. Okay, to 3SF, you get 3. Actually, no, not 3. My bad. My calculator there is 2.45. Here we go. Don't forget your units there. You found the acceleration of A. You found this. Do you not forget to find the tension? How would you find the tension knowing A to be g over 4? Substitute back into either equation 1 or equation 2. I would choose equation 2 because I could make t the subject. T equals 3a plus 3g. So t equals 3a plus 3g from equation 2. I know a to be g over 4. So we 3 times g over 4, 3g over 4 plus 3g. Add this fraction up. You will get your 15g over 4, and that should, again, you plug that into your calculator, you should get 36.8. Don't forget the unit. Tension is a force. 36.8 newtons to 3 SF. Very simple. Okay, so what did I do? First, I resolved the forces, right, on each particle separately. So going down, okay, on the 5g minus t, 5g minus t equals 5a. That's my first equation. Going up, the tension must be bigger than the weight here of the 3g, so t minus 3g equals 3a. Okay, equation 2. A pair of simultaneous equation here. Adding them, get rid of t. That makes 2g equals 8a. A equals g over 4 or 2.45. Substitute the value of a into equation 2, and you have your tension as 36.8 newtons. Very, very simple there. Okay, right. Pause the video, copy this example in your exercise book, please. Okay, let's move on to part B. Find the velocity of A just before it hits the ground. Okay, how would you do that? Call upon your Sievert equations there. All right, that's what you must do. Write down the Sievert values for A. So we know that it says A is 2 meters above. So we got our S equals 2. Okay, right, the system was released from rest, so our initial velocity is 0. We are asked to find out V, so that's what we want. So we don't know what V is. V is unknown. That's what we want. And L, we know A from our previous question. A was G over 4, or we could just say 2.45. Okay, we know that. So H, U, we want V, and we're given A. Okay, so what would you use? Your Silvat formula will tell you that V squared equals U squared plus 2AX is the appropriate one to use. Okay, simple. All right, so we want V squared, that's V, equals U is 0 there. We've got 2 times 2.45 times 2. Okay, and when you square root everything, okay, sorry, I'm pausing because I'm doing it on my calculator at the same time, you should be getting V to be 3.1304 going up. So to 3SF, 3.13 meters per second. There we go. Easy. Very, very simple. Okay, so you have your Silvat equations. Do you know? Obviously, I know that chapter is not buried dead and gone. It's been brought back into anytime there is motion, especially when Newton's second law applies. So what? 8 meters, 2 meters above the ground, released from rest, and we know that our U equal to 0. We need to find V. Okay, we worked out A from the previous question, so we use V squared equals U squared plus 2AX. Easy stuff. Okay, once again, copy this example in your book. All right, let's move on to part C. Part C.